Hello. Okay. Um, Starting with number 156, you have to buy Leetcode Premium to see the problems. So I bought Leetcode Premium because I want to at least get through the first 200 problems on Leetcode. I thought about just skipping through the free ones, but I like that my videos have 5 problems per video, so it would have been weird to start skipping through and not having not knowing where to find a problem, basically, because it wouldn't be 5 at a time, or if it were 5 at a time, it wouldn't be evenly split between them, because I'd have to skip a bunch. But with that said, we've got Leetcode Premium now, so we can get started. Number 156, binary tree upside down, premium, medium. Given the root of a binary tree, turn the tree upside down and return the new root. You can turn a binary tree upside down with the following steps. The original left child becomes the new root. The original root becomes the new right child. The original right child becomes the new left child. The mentioned steps are done level by level. It is guaranteed that every right node has a sibling, a left node with the same parent, and has no children. It is guaranteed that every right node has a sibling, a left node with the same parent. Every right node has a sibling, a left node with the same parent, and has no children. It's guaranteed that every right node has no children. What? Oh, okay, it really is. This is just such a weird procedure because you're changing the links. I guess I was picturing at first that like you grab the 4, you pull it up, and then you keep the links. But that's not what's happening. You have to point here, and then 2 needs to point to 1 and 3. I don't know. I have a hard time picturing what exactly we're doing, but it's telling us exactly what the steps are. Whoops, I forgot to start the timer. You can turn a binary tree upside down with the following steps. 1, the original left child becomes the new root. 2, the original root becomes the new right child. So is it telling us that we can just recursively we can just do this recursively and it'll give us the right answer? So if not root, return none. Root.left becomes the new root. The original root becomes the new right child. So new root dot right equals right child. So or the original root. Okay, so root. And the original right child becomes the new left child. So new root dot left equals original left child, which would have been root dot left. This doesn't make any sense. This is not going to work. Because I'm not doing anything recursive here. So what I need to do, well, I didn't expect a time limit exceeded because I'm not doing anything. That's really confusing. Oh, maybe I'm making a loop, a circular tree, and it's getting stuck evaluating it. So the thing is, this, I think, calls itself recursively on the left side. What do you do if you didn't have a left child? If not root.left. That means we know we won't have a right child also, because it told us that. Guaranteed that every right node has a sibling. So here we can just return root, I guess, because we are a leaf node. Okay, we've got a time limit exceeded, so we have to actually commit to understanding what the hell the question is asking. I just have to look at this image until I become enlightened. So every left child is going to end up pointing to its right sibling. This is not the right way to recurse here. What's the right way to recurse? Well, I guess for one thing, we know this is a weird kind of tree where right nodes never have children, so it only goes down along the left side. But we are moving 4 all the way to the top. So we recurse all the way down, and then at the bottom, we point ourselves to our right sibling. So at 2, we're going to say 4 becomes the new root. 4 points itself to its right sibling. That's not what I'm doing here. Root.right is how you point to your right sibling. So recurse down, 4, point yourself to the right. Then new root.right equals root. So then 4, also point yourself to 2. Okay, so now 4 points this way and this way. And that's when we were recursed down to here. So now we backtrack back up. We returned 4, so now we're going to say 4, point yourself to 3, which we don't actually want. So don't recurse here yet, I guess. This can just be root.left. And then do you recurse here? So from the root, doing this recursively is giving me so much trouble. I think I want to forget the recursion and just do this iteratively. Because it's easy to get to this state, I think. You just do like while root.left. Root equals root.left. We're treating it like a linked list basically. So we go down left. Before we do root.left dot your new left side or I guess, yeah. If I'm at 1, I want 2 to point to 3. So root.left equals root.right. But the problem is we lost information here. So we're going to want to recurse first. I guess that's the problem with doing it iteratively is I want to go... I want to do the work on the way back up. I mean, I could just make a... I could make a stack. Let's make a stack. Stack equals this. Stack.append root. Let's not call it root, let's call it current. While current, stack.append current. Current equals current.left. Okay, and now we want to pop from the stack. So while stack, stack.pop node dot, so now we're going from the bottom to the top. If node dot left. Actually, we can just skip processing the bottom one by doing stack.pop. We don't need to process the bottom, the leaf node. And then we don't need an if here. Here we can just do node.left equals, or so here I would be at 2. I would mean node.left dot left equals node.right. Okay. Then at the end of this, we're in this step. No, we've only done the right pointing. We haven't done the up pointing. But that we can do at the same time. So node.left dot right equals node. And then at the end, you just return you would want to return the bottommost, which is going to be this. Does this make any sense? We're still exceeding time, right? It's still going slow. So I'm still making like a circle somehow. Let's read through this. So our stack starts empty. We're going from the top to the bottom left, and we're appending nodes into the stack. So 1, 2, 4. Then we pop 4 out and we say this is going to be our root. Then we iterate through the stack. So pop, which means we grab this, 2. We say node.left equals 5. So new nodes left is 5. We say node.left, so that's the 4, dot right equals node, which was 2. And then we go up the stack. So now 4 points to 2 and 5, which is what we want. Then we pop 1 out. Here we're popping 1. Node.left, so node is 1, dot left is 2. Dot left is going to be pointing to node.right, so 2 points to 3. Yep, that's what we want. Then node, so 1 dot left, 2 dot right, which was pointing to 5, is now going to be pointing to 1, which is what we want. 2 should be pointing to 3 and 1. Okay, now 1 should be pointing to nothing, but it's still pointing to 2 and 3. So what if we just cleared the stuff node is pointing to? Node.left, node.right equals none, none. How am I popping from an empty list now? What did I, oh, maybe this is just if not root, return none. Oh, okay, yeah. All right, let's submit. 0 milliseconds beats 100%. How can you beat that, huh? Okay. Well, there it is. I don't think I really learned anything. I just kind of did what it told me to do. I don't know what the point of this is, or how you could do this better or worse. Maybe there is a way to do it as you're iterating instead of using a stack. Though using a stack is the same as doing it recursively. So even if there's a recursive solution, that's going to be the same as what we're doing. Okay, they're doing exactly the same stack thing as we were doing. Cool. Next. Number 157. Read n characters given read 4. Premium. Easy. Given a file and assume that you can only read the file using a method read4, implement a method to read n characters. Method read4. The API read4 reads 4 consecutive characters from file, then writes those characters into the buffer array buff4. The return value is the number of actual characters read. Note that read4 has its own file pointer, much like file *fp in C. Definition of read4 parameter. Character array buff4 returns int. Buff4 is a destination, not a source. The results from read4 will be copied to buff4. Below is a high-level explanation of how read4 works. The first call of read4, we read 4 characters from the file, hence read4 returns 4. The second call of read4, we read 1 character from the file, hence read4 returns 1. The third, fourth, etc. calls of read4, we read 0 characters from the file, hence read4 returns 0. I think this is some badly formatted code that was supposed to have some backticks around it in Markdown. This is a lot of text for what seems like a really simple question. Method read. By using the read4 method, implement the method read that reads n characters from file and store it in the buffer array buff. Consider that you cannot manipulate file directly. The return value is the number of actual characters read. Definition of read. Char buff int n returns int. Buff is a destination, not a source. You will need to write the results to buff. Note, consider that you cannot manipulate the file directly. The file is only accessible for read4, but not for read. The read function will only be called once for each test case. You may assume the destination buffer array buff is guaranteed to have enough space for storing n characters. Example 1, input file abc n equals 4, output 3. After calling your read method, buff should contain abc. We read a total of 3 characters from the file, so return 3. Note that abc is the file's content, not buff. Buff is the destination buffer that you will have to write the results to. Example 2. File abcde n equals 5, output 5. After calling your read method, buff should contain abcde. We read a total of 5 characters from the file, so return 5. Input file abcd1234 n equals 12. After calling your read method, buff should contain abcd1234. We read a total of 12 characters from the file, so return 12. I guess the example I was interested in is, what if you read less than 4 characters? Or, yeah. Is it okay that you've left the pointer not in the right place? And are you supposed to return the int of where the pointer is now, or the int of how many things you put in the buffer? Because they probably say that somewhere. Number of characters read. Okay, so this will always be a multiple of 4. Okay, the read4 API is already defined for you. Param buff4, a list of characters. Return an integer, def read buff4. Okay. I think this is really simple. I don't know why they had to give me so much text for this. It's basically, I want to divide n by 4. And read 4 that many times. Right? I want to divide n by 4. I want to round that up. So 0.5 plus n divided by 4. Turn that to an int. Adding 0.5 is and then, so int takes the rounded down value. If I add 0.5 and I take the rounded down value, that's the same as taking the rounded up value. So this is how many times I want to read. So let's just call this times equals this. The destination buffer is a list of strings. I'm guessing it's a list of characters. Return type is the actual characters read, so that's going to be return 4 times times. And then I just need to set the stuff into the buffer, so for blank in times, in range times. So do this times read 4, pass in the buffer. But I shouldn't pass in the buffer because now I'm going to put in more characters than I mean to. Do I just want to strip off the last few? Or do I want to make a temporary buffer that then copies into the real buffer? Buff doesn't take another argument, right? Just buff 4. Okay, so this is going to read characters. All right, how about this instead? N divided by 4, or instead of doing divided, I'm going to use this thing called divmod, which is a thing in Python that gives me the divisor and the remainder. Or not the divisor, it gives me the result of the division and the remainder. So so you read into the buffer this many times. You read one more time if there's a remainder. So times plus equals bool of remainder. This means if remainder is 0, you're going to be not reading more times. If the remainder is 1, 2, or 3, you'll read one more time. And then at the end here, we'll just remove remainder stuff from our buffer. So for blank in remainder. Buff. Or here, this is the other way to do it. No, I can't do it with a slice because I have to actually edit the buffer. How do I remove stuff from a list in Python by index? Buff.remove. I guess this is why the intermediate buffer would be helpful, because then I could just not copy it. Why don't we do the intermediate buffer? So intermediate buff equals this. Grab it from the intermediate buff, and then, well, you know what? These ones you can just go directly to the buffer. These ones you go directly to the buffer, and then we have, for the remainder, intermediate buff equals empty list. If remainder, so if we even have a remainder, intermediate buffer, read 4 into the intermediate buffer. And then for and then you take for blank in, or how do, why am I saying this? The real buffer dot extend. So in other words, plus equals intermediate buffer up to remainder. List assignment index out of range. What does that mean? So while doing read 4 into the intermediate buffer, oh, it assumes that it's a certain size. So we can say 4. Or wait, it can have nothing in 4 slots. I ended up with an extra space when I wanted to read more than there was. So I don't know where that extra space came from. Where's that extra space coming from? Print buff, print intermediate buff, and print times remainder. Let's just take a look at what's going on. We've just got a ton of spaces in our buffer. Oh, that must be how it's initializing the buffer. We're doing nuns, it's doing spaces. But how are we supposed to know that? Because it's saying give me 4. I gave it 4. All right, print me the buffer up to 10 characters so I can actually read it. And then at the end, print it again. So we're saying 4 divides by 4 evenly, so remainder will be none. We're just going to copy into buff. Which we do. Oh, wait, read 4 tells me how many characters actually got copied. I forgot about that. So actually copied equals this. If actually copied is less than 4, or how about we save actually copied out here, and we plus equals it here. So now we have a count of how much has been copied. So at the end, we just return how much was actually copied. Actually read is what they are calling it. And then over here, we're doing one more read for, yeah. So this needs to increment this as well. Okay, that solves this case. A, B, C, D, E. We're missing the E. So we've got A, B, C, D. And then our buffer, our intermediate buffer, is going to be E none none none. We could just initialize these to empty strings like the thing outside is doing. But then when we add E none none none, oh, because we're trying to add it to the end. But we should actually add it to the buffer. And then why do I need, why do I need, I guess I don't know why I need any of this when I could just read one more times than I need and return actually read at the end, right? I don't even have to conditionally read one more time than I need. I can just always read one more than I need to. So I would just say times equals 1 plus n over 4. And then just read a little more than you have to. Why wouldn't that work? How can my output be in the wrong order? Oh, because I'm overwriting my buffer. Okay, so let's delete a bunch of stuff. Have a cleaner slate here. I'm overwriting my buffer. What I want to do is have my own buffer. Let's call it buff4 equals this. always grab from my own buffer, and then buff from we can remember this I, and we can say I times 4 up to actually read, or I times 4 plus actually read equals buff 4. I'll explain what this means. Oh, I've got a bug. Oh yes, I already forgot that the reason I was doing that remainder stuff is because I don't want to copy too much. Let me explain what I'm doing here for a second. You probably know that you can slice lists to get new lists back, but you can also assign to a slice to override multiple. It's like doing multiple assignments in one go. So I'm setting the value of I times 4, I times 4 plus 1, I times 4 plus 2, etc. Okay, but now the problem is I'm reading too much. So it's not just that I can just always do one more than I think I need to. So let's do times and remainder again, and we'll go back to doing div mod of n and 4. So times will be an underestimate. Then we have to do it one more time if remainder. Buff 4, we don't have to keep declaring it. We can just keep overriding it. And then here we do this. This is the same. I want the leftover I. I could also do, no, yeah. I want the I as it was when the loop ended. I want this to go up to the minimum of whatever was actually read and the remainder. So whichever ends first. This makes it look like I'm not assigning to the right cells. I think actually I just need to do I plus equals 4. Oh, we're close. We're close. So did we read the E out of this? E, B, C, D. Because we're reusing the buffer, we got B, C, D at the end of it, which won't matter because we're trying to, oh. Yeah, it does matter because I forgot to slice this buffer. So this goes up to here also. End equals this, end. So the buff looks right. Tell me what I and end are. I is 4. Which is what I expect. So that is the right starting place. End is 1, which is also what I expect. So I guess I don't know why this isn't working. I'm probably doing something wrong in Python that I don't know about. So if I have E, B, C, D, and I take a slice from up to 1, which is what end is, that's just E. Now if I have a list that's like 0, 0, 0, 0, 0, 0, and I slice it from 4 to 5, and I set that equal to this. I guess I need to assign this list L equals a bunch of zeros. L from 4 to 5 is that. And that's exactly what I want. I wanted to put an E in that slot. Because this is going from 4 to 4 plus end. We know that end is 1. And then we're assigning a buffer from blank to end, which puts an E in the 5th slot, which is what we want, but that's not what's happening. Why? Print buff. Print the first 10 things in buff. We're not getting an E here. I'm missing something obvious. I just don't know what it is yet. How about you print me buff 4 ending at end? That's E. How about you print me buff from I times 4 up to I times 4 plus end? That's empty string. Why is this not working? Buff up to 10. Why is it not setting an E? We just checked and it's supposed to. Wait. This is supposed to be I plus equals 1, not plus equals 4, because then we're multiplying it by 4. Okay. Okay. So this is not working yet because we shouldn't be returning actually read. We should be returning basically, how do I say this? Actually read should plus equals the minimum of remainder and read for. Can I just call this end everywhere to make my lines way less long? I starts at 0. So if I do that, then instead of doing this, I can do, I can increment this and do while I less than times. Okay. All right, so that is not a complicated problem. It just took a lot of, I don't know, it's the kind of problem where you're off by 1 all the time. Let me just explain the solution in case some of this is confusing. We can only read 4 characters at a time, but we're being asked to read n characters. So this is how many times 4 goes into n, and this is the remainder. So this is going to be a number less than 4, possibly 0 if the number was divisible by 4. So we start by just, this is the easy part, we read the characters 4 at a time into our buffer. And then if there's still more, and then we use a slice index, like assignment to do that. If there's still more we need to read, then we read 1 more time. The other thing I just realized is we could end early here if we see that we've read to 0 bytes. We could end early. I wonder if that would help our standing. Actually read if actually read is 0, then just return. You don't need to keep working. Wait, then return actually read. Why would this not work? If I read 0, then I should be done. Oh, return end is what I meant. Yeah. Okay, that doesn't actually save any time. so let's not do it. Because it complicates the solution. The variance is so crazy. I jump between 5% and 50% when I rerun. All right, I'm curious to see if somebody if there's like a simpler way to do this than what I've been doing. I do only want to see a Python. No, that's basically it. You have an intermediate buffer. How are they copying 4 characters at a time? They're not. It's just that once they run out of characters to copy in, they read another 4. Okay. Interesting. All right. Number 158, read n characters given read 4 2. Call multiple times. Premium hard. Given a file and assume that you can only read the file using a given method read 4, implement a method read to read n characters. Your method read may be called multiple times. Method read 4. The API read 4 reads 4 consecutive characters from file, then writes those characters. Okay, we already know how this works. We just finished the previous problem with the same definition of read 4. Remember to reset your class variables. Okay. Okay, so it's going to call read multiple times. Why do I care about that? Why is that any different? Is it because when it calls it a second time, it wants to append to the buffer? It wants me to remember where we were in the buffer? By using the read 4 method, implement the method that reads n characters from file and store it in the buffer array buff. Consider you cannot manipulate the file directly. The return value is the number of actual characters read. Definition of read. Yeah. Note that you cannot manipulate the file directory. The function may be called multiple times. Please reset your class variables declared in your solution. You may assume the destination buffer array buffer is guaranteed to have enough space for storing n characters. It is guaranteed that in a given test case, the same buffer buff is called by read. Example. File ABC, queries 1 to 1, output 1 to 0. Okay. So when I read the first one, I have an A in my buffer. When I read the next one, now buff should contain BC. So you're overwriting A. I guess I don't understand why this will be a different solution than the last one. So I'm going to start by just copying the last one and seeing what test case fails to try to understand what it was expecting. So I said A the first time. And then I said nothing the second time. Oh, that's because I already consumed these and I didn't remember them. Okay. Well, this is not that hard to fix, I think. We just need to remember the stuff we didn't use. So, and then start by using those. So, we do need some storage between calls. What did it say to do about that? Remember to reset your class variables declared in solution. Okay. So def init self. We're just gonna have self dot leftover is a buffer with 4. Technically, it can't have more than. We'll just say it's an empty list. It doesn't have to be a buffer. It grows as it needs to. So when you read, you prefer to read from leftover. So if leftover. So grab what you can out of leftover. Buff. From start up to we'll call it end. End equals the minimum between len of self dot leftover. So the amount that I can put and the amount that it wants me to put. Equals self dot leftover up to end. Okay, so I start by grabbing what I can from leftover. At this point, I also want to remove the amount that I've grabbed out of n so that we're only grabbing what's left after that from the read for. And then the last thing here is just if there was leftover in my buff 4, add that to leftovers. So self.leftovers is starting at end, is buff 4, starting at end and continuing the rest of the way. So why don't we print leftovers? I sometimes call it leftover and sometimes call it leftovers. Okay, leftover has B and C. I guess I should clear leftover also. I should self.leftover from or up to end equals empty list. So that that's how you clear leftover. The other concerning thing here is I end up with a space in leftover, which I'm not supposed to. So, I guess here I want to distinguish between ran out of characters and ran out of requested characters. So this is red. And here I want to go only up to red when I'm copying my leftovers. Though actually it shouldn't matter. Should it? It might matter. All right, this is what I wanted to see. This is the right values of leftover at each time. So now let's figure out why we're not reading from the leftovers. Why don't we start by printing end? That's 2. Okay. That's what we expect. What if we print buff? First 10 characters of buff. That's also what we expect. I mean, that's what we expect. Oh, wait. And then I'm overwriting it. Here's where I might want that other optimization where you don't actually do anything if you didn't read anything. Well, actually, aren't I already doing that? We're not copying into buff. You know what else I've noticed is I'm doing all these I times 4s when I could just increment I by 4. And do 4 times times. That'll give the same answer, right? Yeah. Okay, now my issue is I've correctly consumed from leftover into buff, but I need to increment I by that much, actually, because now I want to start a little later in the buffer. So I starts at 0. I should plus equals end. I'm still ending up with no buffer and on the second call. So at the end of the second call, n is 0, right? Because I've already consumed what I needed out of the buffer. Let's print I and n. N is 0. So we're going to say this will be 0 while I is less than 0, so this is not going to run. There should also be no remainder. Oh, and then we're returning end. That's the problem. End also needs to be incremented by I. I end equals 0, 0. Wait. But this is perfect because I'm already... I'm already overriding end here. Okay. Okay. Okay, 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 okay. All right, all right, all right, all right. Okay, we got close. 69 out of 72. What did we say here? 1, 2, 3, 4, 5, 6, 7. We asked for 3. We got 1, 2, 3. We asked for 2. We got 4, 5. We asked for 1. We got 7, but we wanted 6. Where did 6 go? Well, let's start by printing self.leftover on each try. Where did 6 go? So we read 4 at a time. So we would have read 1, 2, 3, 4. 4 would have gone in our leftover. Then we read 2. So we would have read 5, 6, 7. And 4 would have been in our leftover already. So here we should return 4, 5, which we did. Now our leftover should be 6, 7. So when we read another 1, we should have 6. So the problem happened when we read from leftover and wrote to leftover in the same iteration. But 7 is right? Like our leftover amounts are always right. So we read this and we output this and 4 goes in the leftover. Then we read 2, so we should output 4, 5, and 6, 7 should be in the leftover. Okay, so our leftover amounts are not right. Here we should have 6, 7, but we only got 7. I don't like that this is... I don't like that read and read are spelled the same. So actually read, actually read, actually read. So you read this, 4 goes in your leftover, and then you ask for 2, which should return 4, 5, and leave 6, 7 in your leftover. We are returning 4, 5. We're not leaving 6, 7 in our leftover. So there's something wrong here. Print. What is buff 4 at this point? So five, six, seven. I'm printing too much stuff. It's getting hard to read. 1, 2, 3, 4. That's the first time around. The second time around, it's 5, 6, 7. And I would expect for 6, 7 to go in our leftover. So buff 4 is that. What are all the other things? What's I, what's end, and what's actually read? I is 1, which means you're starting here. End is 2. Which means you're ending here. Uh, wait, I is 1. I is the index into the buffer. So we put 4. We put 4 and 5, and I started at 1 because 4 came from the leftover. So I makes sense. End is end is whatever's smallest between how much we have left to read and how much we actually read. So end is 2, but we never index directly. Oh, I guess we do index into buff at end. So end is 2, so that means grab 2 things from the buffer, 5 and 6. But that's not, is that right? No, that's not right. We need to subtract the amount from the leftover from end. But doesn't that mean we shouldn't have doesn't that mean end is just supposed to be 0 here? Why did I think it shouldn't be? Okay, let's go back to the easier case. You read A, and then you put B, C in your leftovers. And now I want to read 2 things. I should read them only from the leftover. So these will be the same. These will both be 2. Yeah, so just give me 2 and put them in end. Why would that not be happening? Or put them in buffer. Why would that not be happening anymore in this example? Oh, I'm just not returning the right end at the end here. Yeah, so the amount of end needs to be the amount of end needs to be increased by this. But then I think I'm using end for two different things. Like if I had an actually read equals 0, then what am I trying to say? It's not that I want actually read. Let's go back to having end here and just remember that end has two different definitions. So end is the amount that we're going to return at the end. But it's also where we want to index into our buffer. This part doesn't make sense. Why am I doing this? Yeah, why am I ever indexing into end like this? Or indexing using end? What I need to be indexing using is this, not end. So buff for end equals this. End plus equals buff for end. This is buff for end. And this is buff for end. Okay. I know this is hard to understand now. It works. So what are we doing? We can only read 4 at a time, but we have to keep track of the last 4 in case we could get called more than once. Or the last. We have to keep track of the leftovers, the amount that we read but we haven't returned, so that we can remember to return it next time. End is going to be what is the end of the return buffer. I is going to be where should we write into the buffer next. Yeah, and then the rest makes sense. So you try to grab from the buffer if you can. And then when you do, you increment where in the buffer we need to write by the amount that we read. from our leftover, and we decrement the amount that we want to continue reading by the amount that we've already read. Yeah. Okay. And then you read as much as you can, it as a multiple of 4, and then the last remainder that's not a multiple of 4, that's less than 4, you read the amount that was requested, and you write to leftovers the leftover amount. Cool. So it's rated as hard. It's not algorithmically hard. It's algorithmically extremely simple. You know, it's just read the amount that it asks you to read. It's hard because you have to keep track of all these pointers. That's not usually the way Leetcode questions work. Anyway. Next question. Number 159, longest substring with at most 2 distinct characters. Premium medium. Given a string S, return the length of the longest substring that contains at most 2 distinct characters. Example 1, ECEBA. Output is 3. The substring is ECE, which its length is 3. CCAABBB. Output is 5. The substring is AABBB, which its length is 5. Return the length of the longest substring that contains at most 2 distinct characters. Oh, okay. So the 2 distinct characters are A and B. The 2 distinct characters are E and C. So give me the substring that has the most duplicates, but only has 2 characters. Two separate characters. Okay. Well, let's do the typical thing. Here's a naive ON cubed solution, which is to, for every pair, count the chars, keep the max. So for every start and end point, that's what I mean by pair, in the string, you go through that substring. So for every possible substring, go through the substring, count the characters to see if it's a valid candidate, and then keep whichever one is biggest. So this is a horrible way to do it. It's the most inefficient way. Here's a better one. N squared. For each start point, like iterate forwards until it's not a candidate anymore. Keep the max. So that's N squared. It's the same as the N cubed, but we're skipping over we don't keep looking once we've, well, we're doing 2 things. We're remembering the intermediate validities, so that checking whether something is valid is always O1, because you're only checking with 1 extra character. And we're shortcutting by stopping the search once we've found that that a character is not, that a solution is not possible from this starting point anymore. But we can do ON. And that's going to be using this insight that solutions want to be big. This was something we learned last time. That if the solution wants to be big, you can do a 2-pointer solution where you increment the right pointer if you can, and you increment the left pointer if you can't. So the solution, the like current candidate is always growing as much as it can. Inc right if you can, inc left otherwise. So let's try that. L and R is going to be our 2 pointers, left and right index. So starts at 0, ends at length of s minus 1. We're going to do while L is less than len of s minus 1. We want to keep track of what's the best so far. So we can start it at 0. At the end, we're going to return best. Then in the loop, you increment the right pointer if you can, you increment the left pointer if you can't. So what does it mean to be able to increment the right pointer? It means the next character you would consume doesn't put you over 2 characters. So let's have cars be a set. Let's declare that on the outside. This is the number of characters in our, you know what? It should be a hash map because we need to keep count of them. Let's use a default dict so that they always start at 0. Default from collections import default dict. Cars is a dictionary from character to count equals default dict int. I don't need this type hint. It's not doing anything on Leetcode. While L, okay, so if you can consume one more, so that would mean cars of R plus equals 1. I also want a fast way to count I guess maybe let's call this counts. Or let's not do a default. Well, we can do a default dict. The thing is, I want to quickly tell how many characters I have, not just what is the counts. So I don't want to have to iterate through all of the keys to figure out that I have 2 active right now, 2 whose sum is greater than 1. So I want to store the counts, and I also want to store the cars. So cars dot add R and counts of R plus equals 1. That's what consuming R looks like. So yeah, we consume R. We're always growing to the right by 1. If we ever stop being a candidate, we have to shrink the left until we are a candidate again. So I guess if we are a candidate, then we grow right, which would mean if len of cars is less than or equal to 2, then we grow right. So r plus equals 1, and we grow. Otherwise, we grow left. So L plus equals 1. We remove, I guess we should do this before we increment. Oh, wait. You don't add R. And here, okay. S at R is the thing that is the character. S at L. So we want to remove, we want to decrement how many of the character on the left we have. If that amount is now 0, then we also remove it from cars. And then we can increment our left side. And best best is whenever is R minus L while we have a valid solution. How do we know if we have a valid solution? It's when this. So I think this would be before incrementing. Best equals max of best and right minus left. Okay, yes. The other reason to increment the left side is if we're already at the end of the list on the right side. Which is going to make the condition here annoying, but okay, so increment the right side if R is less than len of S minus 1 and we are valid. And I'm outputting 1 too many, and I think that's just because I am just off by 1 basically with my difference here. Wait, how did that give, or off by 1 in the other direction? Or off by 1 in the other direction. Okay, let's submit that. I said 0. Okay, so I'm doing something weird here. I'm doing something weird because I'm not checking like I have to do this again outside. The reason it's weird is that oh, what? Why? Oh, you can't really check it outside. The weird thing is I make my solution potentially invalid immediately after incrementing R. Like, I don't have a good place to add a solution. Here I'm doing while, like, I can just do if len of s is less than 2, return len of s. That's gonna, or less than or equal to, I mean. That's gonna solve that, but I think I might, yeah, I'm still like, wait, R is supposed to start at 0. R is supposed to start at the same place as L, and then we continue incrementing it. So nothing is in the set. This does count as a valid solution, which would be equal to 0. Then if R can grow, which it can, and we are valid, which we are, grow R by 1, and increment our candidate. So we start at 0, 0. I think actually we should start with we should start with we should start at -1, -1. Or something, like we need to start with the first character, otherwise we're not considering the first character. Can I start the right side at -1? Because then we would increment right by 1, which would put it at 0. Then we would put the 0th thing in here. Then we would go back up here, and that would get counted as a possible solution. Okay, why don't you print me L and R, and let's see how we are iterating. So we do go to 0 and 3. Which should be a candidate, because that's ECE. Or actually 0 and 2 should be a candidate, because this is 2, so we do need a +1 here. Okay. Can we submit this? All right, so when you have only A, R starts at -1, while L I think this needs to be less than or equal. Okay, less than or equal is the same as less than without the -1. So there's no better way to do this. We got it in O of n. We've got the 2 pointers. You can't do better than O of n. Our 2 pointers are always going up, so we're doing at most 2 times n steps. I don't know why we're beating so few of the solutions, because this is the best you can do, I'm pretty sure. I mean, I guess I could increment by more than 1 at a time, which might... It doesn't actually... it doesn't save time algorithmically, but maybe that would be faster than redoing some of the stuff. You'd only have to set things in the dictionary and the... default dict once. But I don't want to do that because it's the same as what I'm doing, but and I don't even know if it would be faster. It would just be like it would be an idea. Like, I guess in theory that's a bit less stuff because you don't have to do this max every time. You can do it once, and you don't have to look into these things. You could do it once, and probably the slow solutions have a lot of repeated letters, so you could just skip over them. I mean, you're not actually skipping over them. You still have to look at them, but you could reduce the amount of work when there's repeated letters. Let's take a look at solutions. Is that what people are doing? Actually, they're doing it in a more direct way. I did like the general 2-pointer thing that works for any kind of problem like this. And they're taking advantage of the fact that you only need to check if it's equal to one of 2 characters, so you can just store a variable for each character. Okay, cool. All right, next problem. Start the timer. Number 160, intersection of 2 linked lists, easy. Given the heads of 2 singly linked lists, head A and head B, return the node at which the 2 lists intersect. If the 2 linked lists have no intersection at all, return null. For example, the following 2 linked lists begin to intersect at node C1. The test cases are generated such that there are no cycles anywhere in the entire linked structure. Note that the linked lists must retain their original structure after the function returns. Custom judge. The inputs to the judge are given as follows. Your program is not given these inputs. Okay, I don't think I care about the judge. We're just returning a node, right? Yeah, we're returning a node. And we want the first one. Is that what it's asking for? Return the node at which they intersect. So C1, yeah. Okay. So, and like, okay, so here's one easy way to do it. You go to the end of both lists, you iterate backwards from them, and then the first time that you have a value that is different in both lists, or a node that's different in both lists, you return the node before that, or after that if you're going from left to right. In order to iterate backwards over a singly linked list, we need to store O(n) space, because we kind of have to, we need like a stack for each one, or to do a recursive thing and to do it on the way back in the recursion, which would also take up O(n) space for the recursive calls. Is it giving us a constraint like, aha, okay, can you do it with only O(1) memory? That's the fun part. So we can do it the other way easily. You make a stack, you add stuff to the stack. Like let's do that just to have that solution. So stack 1, stack 2 equals these. For let's call it cur equals head A. While cur stack 1 dot append cur equals cur dot next, and then we do the same. Cur equals head B, while cur stack 2 dot append cur equals cur dot next. Now we've got our two stacks, so we just go through them backwards. While stack 1 and stack 2, node 1, node 2 equals stack 1 dot pop, stack 2 dot pop. If node 1 is not equal to node 2, or how about we say previous equals none. If they are equal, prev equals node 1, and then at the end return node 1. So this will give the right answer, as long as we write it with valid syntax. Or maybe it'll give the wrong answer. Why is it giving the wrong answer? I said it intersected at 4, it actually intersected at 8. How is that possible? Let's print stack 1 and stack 2. That's too hard to read. Stack 1 is 4, and then 1, and then 8, and then 4, and then 5, and then, or yeah, just, and then 4, and then 5. Wait, why is this printing so much stuff? Oh, because that's just the first node. why don't you print n.val for n in stack, and then do the same for stack 2. And I guess it's telling me that this is a different one. Can I print hash of n so I can tell which one it actually is? Can I do hash of n mod like 10, so, or maybe mod 100, so that I have less stuff to look at? Okay, so 29, these are the same, these are the same, these are the same. And then these are different. So the 1s are different, the 8s are the same. If I'm popping from the end, I should say these are the same, these are the same, these are the same, these are different. Wait, why did I say, okay, I meant to say return prev. That was the problem. Okay. So here is a fast. So this is O(n plus m). Solution that takes O of n plus m space, because I had to have a copy of both lists. Let's just write that out. O of n plus m time O of n plus m space. Now what we're looking for, let's comment this. What we're actually looking for is O1 space. Which would be fine if we could walk backwards over the list. So, which we can't. One way that we could do that is if we modified the list on the way back, on the way forward, like as we were iterating forwards, we modified the list so that all the arrows point backwards. But it told us don't touch the list, right? Must retain their original structure after the function returns. So it can't be that. Like, a cheating way to do it would be to reverse them, iterate over them, and then reverse them again so that in the end it's the same. But I think that goes against the spirit of the question, because that's kind of like using O of n space. It's just that you're using it inside the input. So let's think, how can we do this while actually just walking from the left to the right? So just to state the obvious, you can't just start the two on the left and the right and then iterate forwards until they agree, because they could have a different amount of run up until they agree. What we can do is find out the length of both lists. If you find the length of this list and the length of that list, then by skipping ahead by the difference, find the length of both lists. use that to synchronize their walker, to synchronize our index, go until the nodes match at the same index. Okay, cool. All right, so cur equals head A, while cur plus equal, or cur equals cur dot next. Length 1 equals 0. Length 1 plus equals 1. Do that again for B, length 2, length 2. Okay. Now for the difference between them, diff equals absolute value of, well, no, we have to know which one is longer. So if length 1 is greater than length 2, then we want to skip ahead in the first list by the difference. So for blank in range length 1 minus length 2, head A equals head A dot next. If it's the other way around, length 2 minus length 1, then head B equals head B dot next. Now we just iterate both until they're the same. So while head A is not equal to head B, head A dot head A equals head A dot next. Head B equals head B dot next. And then at the end, return head A, which is either going to be none if we didn't find anything, or it'll be the value where they meet. Submit. Ta-da! Very cool. Yeah, it's very cool. I could rewrite this thing a little bit by turning this into a while instead of an if in the for. So I could be like, while length 1 is greater than length 2, you do this and you decrease length 1 minus equals 1. And then similarly, while length 2 is greater than length 1, head B length 2 should give the same answer, but a little less indentation, which makes it a little easier to read in my opinion. I wonder why we're on the right side of the curve. What are people doing that could be better than? Oh, actually, probably the cheating solutions are better than that because you can do it with. If you do it with the extra space, you might be able to save time. All right, there we go. Thanks for watching. Please upvote me on Leetcode and on YouTube if you found this helpful. But that's all for now. Peace.